Christopher Detranaltes. He is a PhD student in the College of Agriculture in the Department of Botany and Plant Pathology. His research aims to increase sustainability, profitability, and food security in agriculture through the application of host plant genetics. Christopher's fun fact: he satisfies his interest in plants through gardening and maintaining many houseplants. I think we're onto a trend here with the graduate students tonight in houseplants. Christopher has identified and published reports for 3 novel pathogens not previously known to affect soybeans in the state of Indiana. The title of his 3MT talk: Harnessing Biodiversity for the Cleaner and Cheaper Agriculture of the Future.
Modern agriculture has a problem. Every year, countless epidemics of plant diseases break out on farms across the world, posing a major threat to food and economic security. To keep production up with rising demand, pesticide usage has increased by over 260% since the 1960s. But time is ticking for how long the effectiveness of these pesticides can last. In one generation, selection begins for pathogens that are more resistant to our pesticides than their ancestors. The development of new chemicals that are both effective and safe can't keep up. Simply put, we are too reliant on pesticides for maintaining crop production. And if they fail, we'll be out of alternatives if we don't seek solutions now. Luckily for us, plants have been in an arms race against pathogens since their evolution. Millions of years of selection and adaptation has given rise to extraordinary genetic plant defense mechanisms that naturally resist disease. But most of these genes are still waiting to be discovered in our seed banks, and finding them is critical to ending our dependence on pesticides. For the past 2 years, I've been searching for these rare genes, starting in soybean. Soybean is one of the most widely planted crops in the world and accounts for nearly 1/4 of total pesticide usage in the US. Soybean also plays host to a set of highly aggressive pathogens that prey on vulnerable seedlings, killing the plants outright. The most common solution? You guessed it. Large amounts of preventative pesticides. Genetic resistance is not an alternative, at least not yet. By screening the United States soybean seed bank, I've uncovered more than 30 rare soy lines with natural resistance to the most aggressive seedling pathogens. Using a process called association mapping, I'm now studying how resistance is passed down from parent to offspring and identifying the key genes consistently associated with higher levels of natural resistance. Once identified and characterized, these genes can be bred into the modern varieties farmers have come to love and trust. The end result? High-yielding soybean varieties that naturally resist disease instead of requiring pesticides. And soybean isn't the only crop that could benefit from this research. With modern computing power, we can scan the entire genomes of other crops for genes with similar architecture. That means that what we discover in soybean could lead to faster progress in other staple crops. Millions of pounds of pesticides are applied each year, polluting our natural ecosystems, threatening public health, and lowering profitability for farmers worldwide. Restoring natural plant immunity through biodiversity is a sustainable means to freedom from pesticides. It's time to shed our reliance on pesticides before we're left defenseless without them. Thank you.